Hello all, welcome back to my YouTube channel all about VLSI. Hope you're all doing good and I think my voice is audible and my screen is visible. Let me check. Yes, I hope my voice is audible and my screen is visible. So let us start today's discussion. So from this video we are going to start with the discussion of combinational circuits in digital. Okay, so we are going to discuss about combinational circuits. Okay, now so in digital circuits, we have two type of circuits. One is combinational circuit and another is sequential circuit. Okay, digital circuits is divided into two types. Okay, the first type are combinational circuits. Okay, and the second type are sequential circuits. Okay, the second type are known as sequential circuits. Okay, so in this session we are going to start with the discussion of combinational circuits, and we will come back to sequential circuits in our upcoming sessions. Okay, so let us start with the discussion of combinational circuits. So in combinational circuits we have different type of circuits like adders, like half adders, full adders, binary parallel adders, and we have carry look adders, serial adders. Okay, and in subtractors we have half subtractors, full subtractors, comparators. Also we have multiplexers, demultiplexers, decoders, encoders. Okay, code converters, parity generators, so on we have in the combinational circuits. So okay, but what is meant by combinational circuits? Okay, what is mean by a combinational circuit? But what is a combinational circuit? Okay, what is a combinational circuit? So let us consider a combinational circuit. Let us consider a black box. Let us say this is our combinational circuit. It is our black box. Okay. So this black box, which is a combinational circuit, have several inputs. It may have n number of inputs. Okay, n inputs, and it may have m number of outputs. Okay, it may have m number of outputs and n number of inputs. Okay, so in a combinational circuit the output will depend upon the input. Okay, so in a combinational circuit the output is dependent upon the input. The output is dependent upon the input. So in the case of combinational circuits, the output is dependent upon the input. Okay, the output is only dependent upon the input. Okay, so this is a combinational circuit. If the output is dependent upon the simple input, then it is a combinational circuit. Okay, now let us see. Now let us see some combinational circuits. Let us start with adders. Okay, so let us start analyzing with our first type of combinational circuits, which are known as adders. Okay, these are basic combinational circuits. Okay, in adders also we have different type of adders. First we will analyze first type of adders, which is known as half adders. Okay, half adders. Let me draw the block diagram of this half adder. So let us say this is my block diagram of a half adder. Okay, I'm representing half adder with HA. Okay, so this half adder will have two inputs. Let us say A and B are my inputs. A and B are my inputs of my half adder, followed by it has two outputs. One is sum and another is carry. Okay, so for my half adder I only have two inputs. It may be A or B or M and N or X and Y. Okay, it may be different notation, but it only have two inputs. Okay, my half adder circuit has only two inputs and two outputs, which are sum as well as carry. Okay, now so this is the block diagram of my half adder. Okay, with two inputs and two outputs. Now let us see the truth table for this half adder. Let us try to analyze the working of half adder with the help of my truth table. Okay, so let us write my inputs on the left hand side and outputs on my right hand side. Okay, now what are all the inputs we have? Let me change the pen color. Okay, what are all the inputs we have? A and B are my inputs. Okay, and what is the output? I have sum and carry. Okay, A and B are my inputs and sum and carry are my outputs. So if I have two variables, how many possible combinations are possible? So four number of combinations are possible: 0 0, 0 1, 1 0, 1 1. Okay, so these are all the possible combinations if I have two variables: 0 0, 0 1, 1 0, 1 1. Now, in the case of a half adder, if the inputs are 0 and 0, then my sum is equal to 0 and carry is equal to 0. Okay, if the inputs are 0 and 0, then my sum is equal to 0 and carry is equal to 0. Whereas if input is 0 and 1, then my sum is equal to 1 followed by carry is equal to 0. Okay, if input is 0 followed by 1, sum is 1, carry is equal to 0. Whereas if input is 1 0, my sum is equal to 1 and carry is equal to 0. We are just basically adding our inputs. 0 plus 1, which is equal to 1, sum is 1 and there is no carry generated. And 1 plus 0, okay, 1 plus 0 is sum is 1 and carry is 0. And 1 plus 1, my sum is 0 and carry is equal to 1. Okay, so here in this case 1 plus 1, my sum is 0 and carry is equal to 1. Okay, and this is a 1 bit half adder. Okay, it is a 1 bit adder or half adder. That is the size of A is 1 bit, the size of A is 1 bit, and the size of B is 1 bit. Okay, in the truth table also, if you see, the size of A is 1 bit and the size of B is 1 bit. Okay, so this is the truth table for my half adder. If A is 0 0, A and B is 0 0, my sum is 0 0, 0 1, 1 0, 1 0 1 0, 1 1 0 1. Okay, now, so what are all the minterms we have? We have minterms. If we try to analyze the minterms, so for the sum, what are all the minterms we have? Sum is equal to sigma m. Okay, this is the notation for minterms. If you haven't watched the previous videos regarding the minterms and k-maps, please do watch that. So it will be easy and clear to understand this particular video. Okay, so what are all the minterms we have? Sigma m. This is 0, 1 and 2. Okay, 1 comma 2. For sum we have minterms 1 comma 2, and for carry we have sigma m. Okay, sigma m 3. Okay, so if you write this minterms, what you will have, a bar b. Okay, a bar b plus a b bar, and here you have ab. So this is the expression for sum. So finally what you can write, sum is equal to a bar b plus a b bar, which is nothing but a XOR b, which is nothing but a XOR b, and carry, which is equal to ab. Okay, so this is the boolean expression for sum as well as carry. So sum is equal to a XOR b and carry is equal to a dot b. Okay, so this is the expression for sum as well as carry. And if you want to design your half adder using the logic gates, you can use this boolean expressions. How to design it? So let us draw our inputs a and b. Okay, and let us draw the lines for this a and b, and let us connect a to a NOT gate. This will become a bar, and if we connect like this, it will become b bar. Okay, and what is the sum we have? A bar b plus ab bar, or you can write it as a XOR b. So you can simply connect your inputs to a XOR gate. Okay, like this you can connect them. So this is your sum. And coming to carry, you can simply connect a and b. So this is your carry. So this is a half adder logic diagram. The logic circuit which is present inside your particular half adder block. Okay, so this is how you are going to write your Boolean expressions for a particular combinational circuit, and you are going to draw a logic circuit. So what is the first step? The first step is to identify the behavior. You are going to identify the behavior and you are going to tabulate it using the truth table. Okay, you're tabulating your truth table, and from that truth table you're forming your Boolean expressions. Okay, and from that you're forming the logic circuit. Okay, so this is how you are going to uh, design a combinational circuit, and this is the Boolean expression and logic circuit for half adder circuit. Okay, now let us try to analyze our next type of circuit, which is a full adder. Okay, so do remember, in a half adder we have only two inputs and two outputs, whereas the second type we have, 1 minute, the second type we have full adder. Okay, the second type of circuit we have is full adder. Let me change the pen color. The second type is known as full adder. Now let us draw this block diagram for this full adder FA. So in the case of full adder, you have three inputs. Okay, you can give any name to these inputs, and you have two outputs which are known as sum and carry, and let us give the inputs as A, B, and carry in C. Okay, so for full adder you have three inputs, A, B, and C. Okay, whereas for output you have sum and carry. So in the case of half adder you have only two inputs and two outputs, whereas in the case of full adder you have three inputs and two outputs. Okay, let us try to draw the truth table for this particular full adder. Okay, so what are all? You have A, B, C in, sum, and carry. Okay, so these are all the inputs and outputs you have. So total three inputs, so total combinations are 2 power 3, which is equal to 8. Okay, so 0 0 0 0 2 1 1 1 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Okay, 1 2 3 4 5 6 7 8 combinations. Now if all the inputs are 0, sum is 0 and carry is 0. Just we are going to add this 3 bits, okay, and we are going to write the sum and carry. That's it. Okay, here the sum is 1 and carry is equal to 0. Here also 1 and 0. If more than one input is 1, then sum will be equal to 0 and carry will be equal to 1. Okay, and here the sum will be equal to 1 and 0 0 1 0 1, and finally 3 inputs. Okay, 1 plus 1 plus 1, the sum is equal to 1 and carry is equal to 1. Okay, just simply what we are doing, we are simply sorry for this. Okay, what we are doing, just simply we are writing the combinations. Okay. Okay, now just we are simply adding the inputs. Okay, now so in the case of full adder also, this is of 1 bit, so inputs are only 1 bit. In the case of full adder and half adder, inputs are of only 1 bit. This scene is also of 1 bit. Okay, output is also 1 bit. Do remember this. This is also 1 bit. Okay, now so if you want to write the Boolean expression of sum, just write the minterms first. Sigma m. What are all the minterms we have? 1 2 4 7. Okay, sigma m 1 2 4 7. These are all the minterms we have. And for carry, what are all the minterms we have? Carry is equal to sigma m 0 1 2 3 5 6 7. Okay, 3 5 6 7. Okay, so these are the minterms for carry and these are the minterms for sum. And if you draw a K map, okay, so total 8 number of cells for 3 variable K map, total number of cells are equal to 8. Okay, A B C, B bar C bar, B bar C, B C, B C bar, A bar and A. Okay, 0 1 3 2 4 5 7 6. Okay, now we have 1 to 4 7, 1 2 4 7. Okay, no grouping is possible right here. We cannot group the cross. Okay, so the expression will be A B bar C bar plus A bar B bar C plus A B C plus A bar B C bar. Okay, this is C bar, which is nothing but A XOR B XOR C. Okay, which is nothing but A XOR B XOR C. Now, for carry, if we draw the truth table, if we draw the K map, this is A B C, B bar C bar, B bar C, B C, B C bar, A bar and A. 0 1 3 2 4 5 7 6. Okay, 3 5 6 7, 3 5 6 7. We can group this two, and this two. Okay, so what is the expression we have? AC plus AB plus BC. Finally, what? AB plus BC plus AC, which is nothing but carry. So this is the expression for carry. So this is a Boolean expression for carry. And the Boolean expression for sum is AX or BX or C, and the carry is equal to AB plus BC plus AC. So finally, what you can write? Sum, which is equal to, for full adder, sum is equal to AX or BX or C, and carry, which is equal to AB plus BC plus AC. Okay, so these are the expressions for my sum and carry. Okay, and if I want to draw the logic diagram, you can draw it. Okay, A B C are connected to a XOR gate. Okay, and A B C, and for connecting AB you can use an AND gate, AB BC and AC, and you can connect it to a OR gate. It will become for carry, and here it is for sum. Okay, so this is how you are going to design a full adder, and if you want a logic diagram you can note it down, and the Boolean expressions for full adder. Okay, sum is equal to AX or BX or C, and carry is equal to AB plus BC plus AC. So this is about the full adder and half adders in combination circuits. These are the basic adders which we have in the combinational circuits, and using these adders only, these are basically 1-bit adders, and using these adders only we are going to build multiple bit adders. Okay, more than 1 bit. Okay, yeah. So that's all for this session. So if you are having any doubts or queries, you can stay and ask me, or else we can end this session. Okay, thank you. So if you like this video, please like, share and subscribe to my YouTube channel all about VLSI. Okay, thank you.